dealt with this stuff before. We dealt with sine had a reciprocal property, which was 1 over cosecant. Cosecant was 1 over sine. Secant's 1 over cosine. Cosine is 1 over secant, and so on and so on. The weird ones got to be what we called these things called Pythagorean identities. And when we talked about them in terms of what was called Pythagorean identity, the easiest one was that sine squared plus cosine squared always equals 1. Bless you. What that also meant was that you were able to take these equations, if you recall, and manipulate them to solve for one specific value. For example, if I wanted to get sine squared by itself, what would I do with the cosine squared? Subtract it over. So we listed out that within Pythagorean identities, you could do this as well. Okay. Remember, I know it's been a while, but sometimes I don't put thetas or x's or angles in here just because it looks cleaner. None of these properties will work unless they are the same angles, same value theta and all that. It's kind of assumed that they will always be that, because if they're not, you can't do anything about it. Same thing with cosine squared. I can say that cosine squared is 1 minus sine squared. So a little hint when we start seeing these things, whether they are what we call simplify or verify, if you see stuff that are squared, it's probably an identity that you have to move stuff around to. Okay. Same thing with tangent. I can say that tangent squared was secant squared minus 1. Cotangent squared is cosecant squared minus 1, and so on and so on. And I think that's kind of where we left off. And then we did, you had that one, you still had that worksheet, right? We did about a week ago, 2 weeks ago. That one where we said, it was right after we did the first quiz, then we did that quick little simplify, it had all the answers on the bottom. You still have that one lying around? I hope, maybe-ish. I have extras, it's not a big deal. Yeah, it was one of those that had a bunch of little trig equations. Let's see if I can find it here. No, it wasn't on a packet. It was a. Is this one? No. Oh, this one. It looked like this. What's that? Oh, okay. All right. I wasn't sure if that was. I don't remember if I made a hard copy of that one or not. There you go. So it was all online. Okay. So let's just kind of go through a couple of these real fast, just to kind of. I know we did some of them in class that day. Yeah, we started to go through some of those. I didn't collect it because then we said, hey, let's look at this whole screwed up Quiz-orama thing that you get that people choked on. Yeah, a lot of you guys did well because then you remembered, like, oh, that's what that meant. Duh. So you guys got it in your own head and you psyched yourself out for some reason. And I don't know why you did that. So anyway, so when you're going through a lot of these things, a lot of times it stems from, for example, here we have sine, cotangent, and cosine. 11 was the one that I told you guys was going to be really weird.
Yeah.
You got to be careful with it. Okay. So you've got two things that you're multiplying out. Yeah, this one's a little weird. So when you look at this, notice that you've got junk times junk. You've got a binomial times a binomial. So what do you think you wind up having to do? FOIL. So you FOIL this. So we'll have cosecant. Oops. Minus cosecant cosine plus cotangent minus cotangent cosine. All I was doing is multiplying things out. Now, what I want to do, I want to rewrite everything in terms of sines and cosines. Okay? When you have a mixture of reciprocal properties and standard properties, what I mean like cosine, sine, tangent, or cosine and sine, those are my standard ones. Whenever I see mixtures of things, I always want to try to write them as the main properties, because a lot of times things simplify. Okay? Cosecant. Cosecant is the reciprocal property of what? Sine. So I have 1 over sine minus 1 over sine times cosine over 1. Cotangent's 1 over what? Cosine over sine. And then I have minus cosine over sine times cosine over 1. We okay so far? What happens with those middle terms? What's 1 over sine times cosine over 1? Isn't that cosine over sine? So minus cosine over sine plus cosine over sine becomes 0. These two parts cancel out. And I'm left with 1 over sine minus a cosine squared over sine. Everybody see that? Now, do they have a common denominator? Yeah. So I just rewrite it as a common denominator. Okay. Isn't when I see cosine squareds and stuff, that usually means that there's with a 1 in there, which meant there's probably a Pythagorean identity. So sine squared plus cosine squared is 1. Therefore, 1 minus a cosine squared is equal to sine squared. And you wind up with, and what does that simplify to be? And the idea is, and this is new, it's different. This is what we call trigonometric proof, if you will. It's using a bunch of properties and direct substitutions to get something in a basic form. Okay. It can get a little messy. Yes, sir. Sure. This one you're talking about? Oh, the identities? Yeah. Because then I want to show you. Oh, I got it. Okay. Because then I want to show you guys the difference between what's called. Those were what we call simplifies. Simplifies don't give you a solution to work towards. They just say, hey, simplify. Whereas a verify problem will tell you what it should look like when you're done. Okay? Which means a verify problem will have this little crazy thing called an equal sign. And you just have to show how does it make it get to it. All right? Now, in the few years that I've been teaching this, a lot of times students have a tendency, because they know what the answer is supposed to be, that they make up a lot of stuff. Just so you know, I know how to do this stuff, And yes, there are more than one way to do any of these. But a lot of times when people start making stuff up, I can tell that you're making stuff up to make it look like you're doing something. Don't make stuff up. Mm-hmm. Your best not to make stuff up. How's that? Rephrase it. Can I go and show you that now? Okay. Almost there. Almost there. For example, let's see if I can get to it. Verify. Verifying identities means that you need to show that the stuff, and we generally are going to work from left to right. We usually do what they call a left to right verification. It is very rare that we do a right to left. So just keep in mind, you always want to show that the left equals the right. So if I have cosine times secant, how do I show that that's going to equal 1? Well, isn't secant the reciprocal of cosine? So doesn't that just equal, well, cosine and thus is verified. Okay. It is exactly like a proof. This is more of what a proof is going to look like because it tells you what it's going to be in the end. You just have to know how to get there. That's the idea. Okay. Let's see. Tangent, cosecant, cosine equals 1. What do you think you should do first? Change everything to sines and cosines, right? So if I have tangent, cosecant, cosine, tangent is, tangent sine over cosine. Sine over cosine. Huh. And now we're back to it. Okay. What's that? Well, come on now. I can't. This can't be easy all the time. So this is cotangent squared over cosecant, and you want it to show that it equals cosecant minus sine. Okay. Now, here's one of the tricks for these things. If you start with a singular fraction and it wants you to show that it's 2 parts when you're done, what I mean, like there's something subtract something, something add something, that means that there had to have been a common denominator created. If you start with 2 things and it becomes 1, again, that means there was some sort of a common denominator. So that's telling me in the back of my mind, I got to figure out a way to take cotangent squared, which is a numerator, and write it into 2 parts. Well, cotangent squared is one of the Pythagorean identities. Okay. I believe it was 1 plus cotangent squared equaled cosecant squared. So what I'm doing here is that I know that cotangent squared is going to equal secant squared minus 1 all over cosecant. Oh, I'm sorry, cosecant. I'm sorry. Thank you. Sorry about that. So what I'm doing there is by taking the numerator, which was a single term, by splitting it into its Pythagorean identity, it gives me 2 terms. Notice those 2 terms now have the same denominator, don't they? Which means I can split a fraction apart. It's saying that I can take a fraction apart now. Now, you've done stuff like this before. It's the same thing. It's the exact same thing. You didn't normally do that a lot of times, but this using the same properties. Okay. What's cosecant squared divided by a cosecant? Cosecant. And what's 1 over cosecant? So this simplifies out, and you get cosecant minus sine. And you're verified. You're using some quick properties to get you there. Okay. And honestly, more often than not, they're usually 3 steps, maybe 4. Sometimes they don't go past that. They can, but not that often. Yes, sir. They will all be able to. If it says verified, there's got to be some sort of a way to get it there. Okay, there will be some way to show it. I've had problems before where, you teach this once a year, and I've been using. There's a worksheet I'm going to give you guys tonight that we've been using. Geez, I got it from when I first started 12 years ago, or 13 years ago. I got this worksheet that was old back then, and it's just an awesome set of problems. And there are a couple of them there that every year I look at going. So you will see me walking around with this a lot over the course of the next few days because I'm doing all of them to remind myself of how to remind you of how to do them. A lot of times for some of the more difficult ones, this is the time of year I love to put all the answers to things on the windows because it scares people because some of them look really, really awful. So I'll write on the glass window with the Sharpie, not Sharpie, but, Well, a Sharpie will come off, right? Here, give me a Sharpie. You got a Sharpie?
No.
Sharpie comes off on that, right? You got a Sharpie? You sure? Don't hit somebody in the head. All right, here you go, ready? Let it dry. See how fast it goes? I'll make it. Anyway, we'll see how it goes. All right? You ate a what?
A live worm.
You do?
I was 5. I mean,
I once knew a kid when I was little.
Well, I guess.
not so scared.
Oh, keep those things down. Here.
No, I can't. Why? I'm so happy.
All right. So here's another weird situation. The smug look of like, fine, you win. Notice the denominator of one side and the numerator of the other side. Okay. Now, remember when you did stuff like this? What did you have to multiply top and bottom by to get rid of the I in the denominator? What do we call that? Remember? A nuisance. Yes, that's helpful. All right. What if I did this? Make it less. No. I'd have to multiply by what's called the conjugate. The conjugate to that of 1 plus root 3 would be 1 minus root 3. What you're doing, guys, is that you create, remember when you did this, you created, by multiplying that out, a difference of squares. By doing that, you eliminate the middle term, and you're squaring the ends. Okay? You're basically going to wind up doing the exact same thing whenever you see this idea that you have 1 minus a singular term. More often than not, that means you want to multiply by a conjugate. It works the same. Sine over 1 minus cosine. What is the conjugate of 1 minus cosine? 1 plus cosine. So if I multiply top and bottom by 1 plus cosine, I'm still multiplying by some factor of 1. It just looks really, really weird. Okay? So if I do that, when I FOIL out the denominator, remember, I'm going to get, excuse me, if I do this long form, I'll get 1 minus cosine plus cosine minus cosine squared, which is 1 minus cosine squared. Numerator, I just FOIL. Okay? If I FOIL my numerator, well, actually, let's just write it out first. We'll just say it's sine 1 plus cosine. Okay. So the numerator, or I'm sorry, down here, those two drop out, and I get 1 minus cosine squared. Well, hey, look at that. 1 minus cosine squared, I'm seeing a 1, and I'm seeing a cosine squared, which is, what's 1 minus cosine squared? Sine squared. So this becomes and now what simplifies? Sine. One of the signs drop out and you're done. Because we're going to be able to solve trig equations that have some identities to it. It's a thinking process. Can you get yourself out of a problem? Can you think your way out of a problem? Can you find a solution to a problem given information? Are you ever going to go on a job interview and say, verify this trig identity or you won't work? No. No, and honestly, a lot of this stuff, it's, why did you have to learn geometry groups? You know, the reason why it's logic and reasoning. Logic and reasoning go through just about every field that you ever get through. No matter what, you have to figure out a way to solve a problem. And these are just more complicated looking problems that there's a way to simplify just by using rules and definitions to get through something. You're welcome. I can give you a snotty answer. Okay? I know, isn't it weird? We're not going to have numbers for about well, we'll have some next week. Is this a simplify or a verify? Simplify. Why is it a simplify? No equals. All right. There's no equal to the love I can give you guys. I don't know. Welcome back, everybody. That works. Anybody else do anything fun besides, a pillow factory in Guatemala? Costa Rica. That's close. Nice. Where'd you go? Nice.
SIU is really, really nice.
Do you go to Carbondale or?
They had dogs,
Mhm.
actual
Salukis, yeah.
and they STI.
Yep.
I just had my sister show me her.
Yeah.
And then one, too big of a camp.
It's huge.
And then two, they don't really care about you.
It's huge. So what's really cool about down in Southern, there's a couple of great places to camp. Red Lake. Red Lake is gorgeous. There's another Army Corps engineer place just north of there that's just, there's no private property on the entire lake, so it's all wooded. It's gorgeous down there. Yeah, it's gorgeous. It's beautiful out there. All right, so what does that numerator look like it's going to wind up doing? A thing. If you FOIL it out, don't you just get secant squared minus 1? Okay. Notice, because you've got the same thing with opposite signs, which means it's a difference of squares. So right away, you should get just secant squared minus 1 over tangent. Okay? Secant squared and a 1, that means, okay, there's probably a Pythagorean identity going on in there. That's all craziness. So secant squared minus 1 is going to equal what? Tangent squared. And it gives you an answer of? There you go. Do you have to go down and write that as sine over cosine? No. Because isn't tangent simpler to write than sine and cosine? You always want to leave your answers, like, you would leave it as tangent. If it was 1 over sine, I would write it as cosecant. If it was 1 over secant, I would write it as cosine. Little things like that. I think you'll get the feel for this as we go into it. It's not going to be as you might think. Well, then again, it could be. This one's too easy. That's too easy.
Actually transcends higher threshold. Where all math. Oh, that's a number.
That's not
Ready.
So remember, we have our identities. We have sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. And then 1 plus cotangent squared is cosecant squared. Okay. So if I have 2 minus secant squared. What? If you do, you want to go left to right though. You don't want to, because if you start working both sides, you're going to wind up with 1 equals 1. All right. Oh, I know what to do. I just want to see if you guys can figure out. All right. Well, obviously, I can't. If I start going into this too far, 2 minus secant squared doesn't get me anywhere because I'd have to bring. If I bring over the secant to here, I get 1 minus secant squared, and that would equal a negative tangent squared. What? All right. So. Everybody okay with that? Okay. Now, if I bring secant squared over and move tangent over, I get 1 minus a secant squared is negative tangent squared. I subtracted twice. No, I subtracted secant and tangent.
Yeah,
I moved tangent to the right, secant to the left. Not really. Yeah, why not? Distance equals rate times time. Solve for rate. What do? You divide by time, right? Okay, if I multiply by time, I can bring it back around, and I'm just moving a literal equation around, aren't I? Okay. I can't work both sides at the same time. Okay. I can do that, yeah, it's an identity. Now, hold on. Did I do that? Isn't 2 1 plus 1? You're like, screw this, I'm out. Or was that the most difficult thing I've shown you all year? Isn't 2 equal to 1 plus 1? Okay, so now I have 1 plus 1 minus secant squared. I didn't do anything yet. No. The 2 isn't over here. Okay. I wrote that just to show you that the next step is 1 minus tangent squared and I'm done. Sorcery! I didn't move anything. You cannot move from both sides. You can only work one side at a time. That's the rules. That's the rules. When you do a proof, do you just write down proof?
Yes. Died and became the king of math.
You see it now?
Yes. I don't want to.
Oh, when I'm saying 3, start at the bottom here, the second number 3. Don't worry about the part that says the oral exercises. Start at the written exercises. And then on the other side. By 3s. Can you count by 3s? Give you that one. Okay. I will write down which ones I need to make sure I do. Some of them aren't bad. Okay. Go through those for tomorrow. I will do my best, guys. I'll do my best to get most of these answers written out. Hopefully, I might have them by the end of the day, and I'll start putting some of them on the windows. If not, probably not for the first 6, because those are pretty easy. But as we get into the verify ones, that's where things can get a little more complicated. I'll try to get some of those for you. And we'll go on from there. Good times. Oh, trig identities.